Hello there. Now, this little video is about negative powers. So, if we had a negative power, such as -1, any number represented by the variable a to the power of -1 is equal to the reciprocal of a. Now, the reciprocal is simply flipping the invisible fraction, that is a over 1, upside down. So, for example, 5 to the -1 equals 1 over 5. Likewise, 0.25 to the power of -1 equals 1 over 0.25. How many 0.25s go into 1? 4 of them. So, if you ever see -1, you just have to make whatever your base number is go under 1 as a fraction. Now, another example is 4/5 to the power of -1. So, because this is -1, we are flipping the things around. Remember I was talking about the invisible fraction before of any number over 1? This time it's a fraction with a numerator and a denominator that isn't 1. So we flip it upside down to get 5 over 4. The 5 and the 4 have swapped places. So you find the reciprocal of a fraction by swapping the top number and the bottom number over. So this idea can be extended to more general negative powers. So if we had a to the power of n all to the power of -1, then this is equal to 1 over a to the n. So if we look at this left-hand side, using our laws of indices, we can see that these powers would multiply together. So we can say, as a rule, that a to the -n equals 1 over a to the n. So, this means, for example, that 3 to the power of -2 equals 1 over 3 squared. Now, if you got told to simplify 3 to the power of -2, this would be your first step, but then of course you can simplify it some more by actually working out the power. So you would have 1 over 9, because 3 squared is 9. Likewise, you could have 2 to the power of -4, and that would equal 1 over 2 to the power of 4, and that would equal 1 over 16, because 2 to the power of 4 equals 16. Now, finally, this is a harder example of negative powers involving a fraction and a power that is not -1. This time, it's -2. So, we must be very careful here. Let us split this up into more bits using our laws of logarithms. So we've got a quarter to the power of -1, and we could say that all of that is to the power of 2. You see, these equal each other because using one of our laws of indices, you can check that -1 times 2 becomes -2. Now, this of course means that the interior of this, a quarter to the power of -1, becomes just 4. 4 over 1 to be precise, but we don't need to mention the over 1 part. Now, this is still inside the brackets that are squared. So, we have got 4 squared. I can ignore that part. We've got 4 squared, and of course 4 squared equals 16. So, we have simplified this side of the equation to become 16.